Hi, I'm August Ladensack. I'm going to explain the math portion of the test. So what we have is we've calculated out a 6-inch bore on our cylinder for this log splitter. Is going to give us well over the 50,000 K figure that we need. From that point, we have a group consensus at 2,500 psi and 16 gallons per minute are going to be our calculation numbers. So with the 6-inch bore, we came up with the square inches, which came into cubic inches. We figured into gallons, and retraction speed was gallons per second. The full gallons divided by gallons per second was 16.5. And then we figured that out with the stroke of the cylinder down to 2.18 inches per second, unrestricted extension speed. Retraction speed we figured out by subtracting out the rod, cubic inches of the rod. It came up to 3.92 gallons in the retraction side of the cylinder, and that came out to 2.45 inches per second. Now on the horsepower, figured out the gallons per minute, pressure, and the constant came up to 23.32. We at 80%. Efficiency gave us 29.15, round up to 30 gallons or horsepower. We used a nomogram to figure out the dash size for the pressure and return, and we're well within the safety limits of the flow rates. On question 7, for the tank size, we had 16 gallons per minute times 2, 32. Branch circuits, about 3 gallons in the branch circuits, and 4.4 in the cylinder gave us 30 gallons. So between the 2 and the 3 times size, we went with 45 gallon as a size for the tank. Then for the oil, we all agreed as a consensus to go with the standard petroleum hydraulic oil, Chevron ISO 10. And for our cleanliness code is 18.16.3, which was the lowest for the vane pump itself. And then for the heat exchanger, we calculated out the heat BTUs developed in an hour. We figured a 50% duty cycle, so divide by 2, 30K BTU hour. Go!
I'm David Smola, and I'm going to show you the practical side of the test. First, we got our pump and the motor and our pressure regulator. Then we got our pressure equipment. The way to regulate our flow rate and all that. View of our flow rate, and our switch to decide which way it goes, in or out. And then we got our piston that we're going to be using for our log splitter for the lifting action on the side, so that we can lift our logs up onto the log splitter itself. In our circuit, we're going to have 2 in parallel, but we only got 1 at the moment, so extend. And our circuit's going to be 36 inches at extension, so bring it up on, and then retract and bring it back down so we can split the log.
Alright, I'm Shelby Newman. I'll be explaining our schematic. So this is our circuit. It's run by a 30 horsepower engine running a 16 GPM pump that flows through a 25 micron filter to a lifter circuit with a 6-inch bore, 2-inch rod, and 36 stroke piston. Then flows through a return line filter to tank.